Hi there. In this video, the tutorial series on programming from the very basics using Python, session 4, we will continue where we left off in the previous session, that is session 3, where I was introducing you to the ingredients of a Python program. In the previous session, if you remember, I talked about statements and expressions at the very basics. I told you what is a statement, what is an expression. I gave you an insight on what an identifier means and what it does. And I talked about variables and so-called constants in Python, the lack of it, and how we actually treat constants by convention in Python programs. And I also gave you some good practices in maintaining your Python code, a very basics of that in terms of spacing and punctuation rules. So today in this particular session, we'll continue to the next important concept. I'll continue with statements and expressions, one more layer deep, where I'll tell you a little more features that you should know about, but I'll also introduce you to some more functions, some more built-in functions. In the previous session, I only introduced you to print, and that too with not much of details, just what a function means and give you an example of print. Today we'll talk about one more function to get input and see some more functions related to the next topic, which is objects, values, data, and data types. All right, so let's get started. If you know about Python code, I told you a program is made up of statements and expressions. And when you're dealing with expressions, you saw me using numbers, right? I try to type something like 1 plus 2 and you got the answer. Okay, let me select the Python runtime. I just started this notebook. All right. I don't know why I get this error. Okay, never mind. It still works. Sort of. Run this now. And you can say 1 plus 2 returns 3. Now, these are numbers. We all know it. We all learned it, right? Now, these numbers represent data. Now, when I say data, I should tell you that a program, if you look at the ingredients of program, at the very high level, you're dealing with data and you have algorithms that operate on data. There was one nice book which I remember reading. I think it's back in the 90s, I think late 90s, when I was journeying into programming that time. I remember buying this book by Nicholas Wirth. It's called as Algorithms Plus Data Structures Equals Program. I searched for the book in my library and it's missing. Basically, a lot of books are missing in my personal library right now because, many times people look at my books and say, can I take this book? And they can, and I don't get it back. I remember buying the C programming language book almost like 6 times, right? So every time somebody takes that book, I don't get it back. I know the book is so thick that, no, I mean, the book is thin, but the concepts are so thick that people would spend their lifetime with the book perhaps. So I won't get it back. I think this book is on the similar tone. Nicholas Wirth was a creator of a very popular language called Pascal. It's a very popular language in the 90s, 80s and 90s. A lot of code was written in Pascal. And not only Pascal, he has also designed Modula 2, and, there a language called Wirth. There are many languages. I would say he's a serial language inventor. Every new language he invents, he comes out with some new idioms and new concepts in dealing with how do you visualize programs. So, and that book which I talked about, Algorithms Plus Data Structures Equals Programs, was a fantastic book. It's a very small book actually, and but nevertheless, the concepts are quite thick in it. And the more emphasis that the book title says that a program is essentially made up of algorithms that operate on data structures. When I say data structure, it's nothing but all these data like numbers and strings and all of those elemental data put in some kind of a structural format. Many of you did some C programming, know about structs and unions and or other languages you'd have heard about records, record types, something like that. Right? If you come from database background, I'm sure you know a record or a tuple, which is made up of multiple columns. Like say I want to represent information about an employee in an organization as a record. That's a structured data. So if you want to represent in a programming language, you create a data structure for it. And different languages provide different syntax and semantics to represent structured data. And then you have some algorithms to use that data in the right form, transform them, or operate on them. What are algorithms? Algorithms are nothing but all these set of instructions following a pattern. The set of instructions or statements that follow a pattern that's try to solve a particular problem, right? So a program is essentially that. In the previous video, when I talked about statements and expressions, I emphasized more about the Python syntax grammar. But first, I will emphasize this time about the second topic, and then I'll go back to statements and expressions again, which is objects, values, data, and data types. When you actually put in numbers here like this, these are actually called as literal values, right? In a program, you're representing this 1 and 2 are also known as literal values. We call them literals. And different languages, different programming languages have some syntax grammar in how you represent these values. For example, the computers work in binary number system. It only understands ones and zeros. And it's all electrical, right? I have a PC on the side, not visible on the camera. So I'm pointing there. Don't worry about that. Or I have a laptop on the side. Anyways, so if you have a computer, today's computers are purely complex electronic equipment. So it's electronics inside. You have all these super complicated logic gates all put in some microprocessors, and they'll get things done. And they operate like switches, like ones and zeros, like on and off switches. The switches can be configured as gates, like OR gates or AND gates and NOT gates, and then creating circuitry using these gates. We create flip-flops and shift registers and comparators and all of this stuff. And slowly you build CPU and many other things out of it. And that's how ultimately when you're writing any code, it has to go to those low-level circuitry as electrical signals and fire up all these switches to do their work. And ultimately the result is highlighted as pixels on the screen, which we now see it as numbers. There's a lot of things going on inside a computer, but all of these are layer by layer abstracted. We have firmware, we have operating systems, and we have high-level software, and then we have language runtimes, layers of abstraction to make our life easier. So even if you don't know much about how the hardware works, you can still write a program and it works naturally. Now, the point I'm trying to make here is that these numbers are our representation. We know this as a decimal number system. Am I right? Decimal number system. We all learned that. So we have 10 fingers, we can count from 0 to 9. That's a decimal number system. Base 10, we call it. But then the computers work in binary numbers. Somebody does a translation. Who is doing it? The language runtime. Here, the programming language takes care of figuring out that when I type 2, the 2 is actually a string. It's read as a data. 2 is read as data, some kind of string data. And it figures out that, 2 from decimal must be represented as binary and then stored in memory and managed accordingly for the CPU. So this literal values are for our understanding. We represent values literally in our way, and we expect the computer to transform it into ones and zeros in binary number system. Now, when you look at this, I put 1 plus 2 and I got 3. Let's try it. Another interesting exercise. If I try maybe 10 plus 20, right? I just copied the cell, by the way. I was too quick at it. I went to command mode, press C, V to copy it and paste it back. I guess you figured it out, right? The last session I told you, you don't want to doze off in my sessions. My sessions you might find it slow. The pace is slow, but I do cover interesting stuff in midway, right? So you don't want to miss it. So how to copy it? Just go to the command mode. So go to the command mode here and press C and then press V back. That's how we copy it, right? If you want to delete the cell, how do you delete it? You say X, right? So you can just go back to command mode and type X. All right, so I just copy this back, and this time I've just changed it to 10 plus 20, and you know what the outcome is? It's 30. No brainer, right? But if I put a 0x here, we are not accustomed to write numbers like this. We don't do it. But if you're a computer programmer, especially if you come from the era of C programming language, you know what this is. This is an hexadecimal literal notation of a number. It's a literal value, but in hexadecimal. So I'm trying to tell the computer that I have a value in hexadecimal, take that and do the computation. So earlier when I just put 2 like this, it used decimal conversion. Yeah, 2 in decimal and hexadecimal will result to the same value in binary, right? But when you put 20 in decimal, you convert a binary, it's in one particular ones and zeros, right? You can do that binary conversion, figure out and let me know. But then if at all I say this is an hexadecimal, value is different. This grammar that you see here is what we call as literal notations and syntax grammar for the literal notation for numbers. So these are literal values which are numeric in nature. But then if at all I try out something else, I put open quotes. This time I'm using double quotes. I always tend to use double quotes, but you can use single quotes in this place. It's going to work just fine on Python. I'm a polyglot. Many languages, strings are represented only using double quotes. Java, C, and all that. So in Python, it's more flexible. But to be very consistent, I always tend to use double quotes. But you're okay to use even single quotes wherever I'm using double quotes. I will tell you when to use single quotes, when to use double quotes. If there is an ambiguity when I talk about string data. For now, when I just put this in double quotes, I put 10 plus 20. Now this is an interesting one. Just try running this and you will see the first error. It's the first time you're encountering a runtime error. So far, in all the code that I showed you till the last session, we hardly did nothing. We hardly did anything. So the scope for errors were almost not there, right? But the first time you're seeing an error here. And this error is a runtime error. There are 2 kinds of errors when you run Python code. Errors in the syntax grammar, we call them as syntax error. It is also under the category called parse errors, and or some people call it as compile time errors. They all mean the same thing. And this is a runtime error. I thought I will talk about that a little later, but it's good to tell you what it is. If at all I make a grammar mistake, syntax error could be an example. I just create a cell above, and if I try something like say 10 plus into 5. Oh yeah. What do you think Python will do when I pass a number like this? 10 plus into 5. Oh, should I add or should I multiply? It's ambiguous, right? You don't know what you're trying to mean here. This is treated like garbage from the language runtime. So the point is when this line is being parsed by the Python runtime, first time it's parsing this line, it figures out that the syntax grammar is wrong. It shouts out an error right away. The good news is in the recent versions of Python, the error messages are very, very intuitive. At least it says invalid syntax, but sometimes you get more details. But here, it shows a cap symbol or a caret sign that you see here, pointing to where it encountered an error. It encountered error here. It was like parsing 10 plus is expecting another operand, but another operator was added. Oh, 2 operators side by side? That looks odd, right? And it actually flagged off an error. It does not continue any further. So if you have a program that's made up of, let's say, 100 statements and expressions, 100 statements and expressions. If there's syntax error in the 98th statement, 2 before last end of the program, 2 statements before, right? Towards the end of the program, if there's a syntax error, not a single line of code is executed. You might need to make a note of this. Syntax errors will be caught while parsing the program. So your Python language runtime does 2 stage of program execution. whenever you ask Python runtime to execute a program, it's not going to read statement by statement and outright execute it. Such kind of execution, we call them as line by line interpreters. There used to be old school languages. Even today, there are few languages that fall in that category. I can remember TCL or Tickle, you call it, falls in that category. It's a line by line interpreter. Shell, bash shell, and all of them, shell scripts are interpreted line by line, statement by statement. So the read a statement, evaluate it, execute it. Read the next statement, evaluate it, execute it. When you have a multi-line code being passed, that's line by line interpreter. Python is a compiled interpreted language. It's a mix of two things, compile and interpret. There are some languages which are purely compiled languages. C is an example. C++ is also an example to a large extent. Some people argue that no, there are runtime also, but I'm taking the basic C compiler. Okay. If you take a traditional C compiler, you write a C program, right? You compile it. You use a compiler tool. If you're on a Linux or Unix like environments, you'll run a tool called CC, C compiler. It's called CC. That's a command. It's a CC and you type hello.c or any file name.c. It's going to read the source code completely, compile it into a binary executable for the appropriate instruction set architecture. That is machine code for your appropriate CPU. And then you don't need the source code. You can just use the binary. The binary will run. Most of your applications on your operating system, they're all binary programs. The programs are all stored in binary format already. Somebody's compiled it, shipped you the binary, and you're using the binary. That's how a lot of software is available in your operating system. Even if I download the VS Code, I believe that VS Code should be some big program binary ultimately. The terminal emulator I'm using here is also a program binary. Web browsers, all of them, they're all binary programs. When I say binary programs, what do you mean is that the source code is compiled to generate a binary executable, and that binary executable is directly executed by the CPU. I mean, through an operating system. So I have to word it carefully, right? So it uses the aid of an operating system software to figure out how the program must be loaded and how that. But yeah, it's ultimately the instructions are all in binary format. This is called compilation. Or these are called as compiled languages. Languages that purely support compilation or compiled programming languages. And these are like, in the real world, compilers are like, let's assume that I wrote a book. Maybe not a book, maybe an essay. I wrote an essay. Not maybe a book, but maybe an essay. You read this entire essay that I wrote in English and you translate that entire essay into another language which you're comfortable with. Maybe you want to translate to French, or you want to translate to, Greek or Latin, whatever it is. You rewrite that you compile the entire essay into a language and you distribute it. That's called compilation. That means you read the entire program, you compile the entire code into the form that the computer understands. These are purely compiled languages. Then there are languages which are a mixture of compilers and interpreters. Python falls into that category. First time when you run a Python program, when you say Python and a file name, for example, or when you run a cell here, the Python runtime reads this entire source code. There's a source code, which is what I wrote, what we write, and what we understand is a source code. So this source code is being read by the Python runtime. It compiles it to an intermediate format in memory. It doesn't store it on disk. Normally it does not, right? For normal scripts, it does not store it on disk. It converts to an intermediate format in memory, an optimal format. This is called as bytecode. The real world analogy to it, it's not very popular today, but this was a time when stenography was very popular. This is prior to computers becoming very popular and mainstream. We had these stenographers, the people in the 70s and 60s. You have a leader or a manager and some big entrepreneur, and they will have stenographers who will make notes. What I dictate, they make notes, let's say. When they're writing notes, I speak in English, but you look at the notes will look like scribbled notes. It's called a shorthand. People who learned typewriting in the early era, maybe 2 decades ago, the advanced, to say part of typewriting, advanced lessons on typewriting involves learning shorthand. That means you make shorthand notes. It's a very optimal way of representing long English words and sentences in a very shortest way. So you can, when the person is speaking fluently at a fast rate, you can quickly jot down notes without having to stumble on writing long words. Right? That's the whole idea. It's like an optimized format. And then using the short code, you will type it off to the typewriter, right? Uh, it's a similar analogy. So when you have a bytecode interpreter, what they normally do is that your source code is parsed. While parsing, it will check for syntax correctness. In Python, indentation correctness also is checked. I'll talk about indentation after a while, right? Indentation correctness. And after all these are checked and everything looks good, it's compiled into the bytecode in memory. And then the language runtime starts interpreting statements of the bytecode to machine code. This is generally a work of a bit of runtime optimization, nothing else, right? Rather than doing line by line interpreting, compile the entire code to an optimal format that's called bytecode format, and then you interpret these statements in bytecode is actually faster and more efficient. To be also more reliable in certain cases. So Python follows that particular trend. While parsing the source code, if it identifies some mistakes in the syntax, use a wrong syntax, a grammar that's totally wrong, or ambiguous syntax like this, like I showed you, it will stop right there. Not a single line of code is executed ultimately. So syntax errors, no matter where it is in your code, even if you have a 1,000-line program, if you have the syntax error in the 1,000th line, not a single line of code is executed. Note this. Runtime errors are a totally different story. The code is compiled. Grammar is no problem. For example, Python did not see any grammatical errors here. You want to add 10 and 20. Yeah. Plus is an operator. It takes 2 operands. The grammar is fine. One operand is 10, though with quotes, which he doesn't really care at this moment. Another one is another operand, which is a number. During compilation, does not know what these types are. It does not know that this is a string, this is a number. No, it doesn't infer that. It just creates a bytecode. But the bytecode is being executed statement by statement. During execution of this bytecode, it realized that there is an error. And that error is a runtime error. There are many kinds of runtime errors. And this error looks very intuitive. It says type error. It says type error. Reading this error is very important. You should always note, most people look at an error, I'll tell you in my live training sessions, classroom trainings, I ask people to write some program and they stumble on some error. And they raise their hand and say, I got an error. What is the error? I didn't read it. Don't be that person. Whenever you see an error, read it. Read the entire lines first. Later on, you'll see a pattern and you'll figure out what's going on. Okay? If you're new by, whenever you see any errors, take your time, try and understand what this actually means. It's showing you it's type error. It says trace back, most recent, call last, and all these. Maybe it doesn't make sense at this moment. Don't worry about that. It says cell info, that is in this cell number 4, line number 1. This line, that's 10 plus 20, is a problem. And what's the problem with this? It says type error can only concatenate str. Str is a short form for string. Python calls string as str. It's a shortened notation. Not int to string. It says can only concatenate string, not integer to string. But I'll tell you what really went wrong here. If I had made both of these, okay, I'll just copy this in, okay? So let this trail be there. If I had made both of these as strings, yes. When I put something in quotes, it's a value represented as a string. So what is the difference? Strings are data. They are some kind of data but they don't represent a value that you can do arithmetic on. You cannot perform any arithmetic on this. It is not meant to be used in arithmetic or mathematical expressions. These are numbers, no doubt. You can see 10 and 20 are numbers, but they don't have a numerical value. Just like real world, you have your employee ID if you're an employee in a company, or maybe a student ID if you're a student in any university, college, or school, or you might have your phone number. These are numbers. Mostly you'll have numbers, right? Employee ID could be a number. I hope it's all numbers. I've seen numbers mostly. And student ID could also be a number. And your phone number is definitely a number. Though it's a number, you won't do any arithmetic on it. Not unless you are some kind of a numerologist. Lucky numbers and all that. Anyways, but I digress. So the point is, you won't. That number does not have any value as such. If I say my phone number is 1152556667, whatever that number is, I randomly made it up. Does that number carry any value? No. It's just a number that uniquely identifies my phone connection. That's it. It does not have any inherent value to it. I can't say that my phone number is expensive than your phone number, or my phone number is better than your phone number. No. Yeah, some people might use fancy numbers and talk about that. Let's not worry about that. Okay, that's a detour. But then, normally, these numbers don't carry any weightage or a value. But if I say that my salary is like $10 million, I'm not sure if anybody is earning that salary as an employee. I'm willing to know. Okay, but then, and one of you say, I'm earning $1,000. There's a value. Age is a value. I can say I'm 47-year-old, and one of you might be saying I'm 18-year-old. Yeah, I'm older than you, obviously. That's a value there. Age, older, younger. So numbers have this value where you can compare each other, we can add them, we can do all kinds of arithmetic. It makes sense, of course, right? When the same numbers are represented as strings, they lose that feature. For example, when I say 10 plus 20 here, these both are actually strings now. And when you try to use a plus operator for a string in Python, if both operands are strings, just see what happens. It's called concatenation. It's like merging two strings. You have one string with 10, another string with 20, they got merged. They don't get added, they got merged. So you can see that Python has a very strong sense of data type. I use the word data type. Now, the string is data, numbers are data, and these operators are operating on them. And they operate differently based on what kind of data they work on. And when there is an ambiguity, they will throw a runtime error, like you just found out in here. But then you can see this concatenation. Normally, very rarely people concatenate numbers unless there is logical requirement. But one of the common things that people would do is, maybe I could just say, I could just provide, say, first name equals John. And I can say last name equals Smith. What am I doing here? Assignment. Remember, in the previous session, I said x is equal to 10 or y is equal to x plus 2. And you remember we were dealing with numbers, right? We said pi is equal to 3.14 and I treated pi as a constant. This is no different. This is an identifier. I call the identifier very aptly as first underscore name. Look at also the way I have named this identifier. This is very important. This is a good practice to follow. Some of you might, who come from other languages especially, might say, I will name it like this. Java developers, mainly. Or people who come from C++ and Golang will do even thing like this. It's a first name like this and it's equal to John. There's nothing wrong in it. The syntax grammar in Python allows you to name identifiers the way you want, as long as they're made up of alphabets, numbers, and underscore. All identifiers in Python must start. I'm just going to put a note here. This is a very important one, so I'm going to add a note here. all identifiers in Python. Let me make this markdown. All identifiers in Python must start with an alphabet or an underscore. This is an underscore, I guess. Everybody knows it, right? It's an underscore. You can start with an alphabet or underscore and can consist of alphabets, numbers, and underscore for the rest of the characters. Which means that if you are going to name any identifier, you cannot call an identifier as 10. That's wrong. Try doing this. This looks so very confusing. If I try to say 10 is equal to 20, oh, people will just go bonkers with this. 10 is equal to 20. Which world is it? Right? You want to tell Python that this is an identifier, and Python just gets confused. It says, no, you can't create an identifier called 10. 10 is a value. You cannot make an identifier out of it. So we try running this. It's obviously a syntax error. It says, cannot assign to literal here. 10 is a literal value. You cannot assign to it, right? So the left-hand side, what you should have here is an identifier, which means, what if I put something like this, underscore 10? I was able to make it work. Don't do this. No errors. No errors. But having an identifier as underscore 10 is a horrible idea. When you're naming your identifiers in your Python code or any language, you put as much emphasis in naming your identifiers like naming your children. I know I'm exaggerating this, but that's how it is. The last thing you want to know is a child that grows up and says, why did you name me like this? It looks so horrible. I would just look at Elon Musk for that. So, is only exception where he's named his child with some all special characters, but most of us use names which are, normal letters and alphabets. Rarely people use special characters in names. Imagine my name is like semicolon, asterisk, percentage, space, underscore, AB 590. What's your name? I don't remember, but if I tell that name, nobody will be able to remember it. So you want to make identifiers easy to read and easy to contemplate and see what it represents. Underscore 10 has no meaning. So don't use identifiers like, though it's supported. You can start an identifier with an underscore or a letter. But after that, you can have numbers. And though you can have numbers, the reason why you would have numbers is like you could just say maybe, phone number 1 and phone number 2 and phone number 3. So if you have multiple phone numbers, or email 1, email 2. So maybe there people use suffixes with numbers. Makes sense there. This is how we do it. And yes, when it comes to naming identifiers in Python, there's a rule that is being followed all through. You don't name like this. Not a good convention. Not a standard convention in Python. And so is this. These both naming conventions could be prominently used in other languages, but when you are coding in Python, follow the Python naming convention. It's like saying, you want to speak English, you want to speak like an Englishman. I could always, when I used to learn English in the school days, we all, in India, we do that. We use the words in English, but our grammar is Hindi or Kannada or Tamil. We call it butler English in India. So it's something like that, right? Don't do that. If you're going to be writing code in Rust or in Java or in C or C++, find out the most common convention that the community follows or your team follows and stick to that. Python world, this is the accepted norm by a very widespread community of Python developers. So follow this. So which means if you're naming your identifier, it's always suggested to use all small letters. Don't use any capital letters for identifiers like these. So when you use all small letters, you're trying to infer that this is a variable that represents any data. It doesn't matter what data it represents. It's a variable. Our variables are just reassignable identifiers, and identifiers are labels. Labels. So first name is a label to this data called John. Last name to Smith. And you can see I'm using underscore for separation, not using these convention. We call this camel case or cap case, right? Cap case or camel case conventions. We are not using that. Cap case convention, however, is used for naming special kind of identifiers like classes, which I will discuss much later. That's the only place where you use. So you can differentiate something called as a class from other entities, right? We'll talk about that much later. For now, all variables and even functions must be labeled starting with a small letter. All small letters throughout, lowercase letters in English, and use underscore. Some of you might even argue and ask me, should I name my variables in English? What if I want to name it in Mandarin? Actually, you can do that. Most modern languages support multilingual names. You can actually name your variable with some accented characters, or you can also use all kinds of Unicode formats. It's supported, though I would not recommend for the sake of portability. But some of you who are going to write program primarily for your local language, then maybe you can use that and follow the rules accordingly, right? When it now comes to naming variables, the convention when you're using standard English is this, right? So you say first name, last name. These are two variables that are there. Okay, I detour a lot because every time I see something, I detour a bit, I talk about some concept, come back again. I keep doing that. Okay, so just go with the flow. Now copy this. I'll copy this. Okay, and coming back here. First name is an identifier that identifies a string that's got the word John. Last name is an identifier that identifies a string that's got the word Smith. Now, and these are also literal data, by the way. These are also literal string representation. I'm representing strings literally, right? So, right. So now here, if I just type first name plus last name here, you can see it's concatenation. The primary use of concatenation is merging strings like these. You have first name and last name, you want to merge it. Oh yeah, I want a space in between. So what do I do? Oh yeah, no problem. If you want a space in between, I'll copy this cell again. And this time, I'm going to put a first name plus add a space, little space, plus last name. John space Smith. Is used for use case patterns like this. This is called as string concatenation. So we call this as string concatenation, which is joining multiple strings together. You'll learn in the later sessions that concatenation is a common feature that's applicable to what we call as sequenced collections. Wow, sequence collections. So what is it? Don't worry about it for now. String is a sequence collection, by the way. So it's a collection of characters, right? So concatenation can be applied to lists and tuples and other types, which I'll discuss much later. So now you can see that for plus operator work as a concatenation operator, both operands must be of the same type, which is a string in this case. If the first operand is string, second operand must also be a string. This plus operator is like chain loading. This is a string, so this must also be a string. If any one of these operands is not a string, it will flag off an error, a runtime error, telling it has encountered an incompatible type. You'll get a type error. Okay, so that's what you should know about. And yes, runtime errors are caught during execution, which means that if you have this kind of a statement where, if at all I put a 0 here, like this, I added a 0 here, this will flag off an error. Now this error is caught during runtime, which means that if any statements are there before it, they will get executed. For example, if I try to put a print before, print first name, comma, last name. We should also note here that print, I'm passing two arguments. In the previous session, when I used print, I just put 3 plus 4. It's a single argument. Result of 3 plus 4. Or print of R, if you remember that in the last session. Print is a variadic function. When I say variadic, it's also called as variable arity. So variable arity or variadic means that it can take multiple arguments or variable number of arguments. You can pass one argument, two arguments, three arguments. And how do you separate these arguments? By a comma. The space is not compulsory, but as you know that I prefer using spaces. And you can see also here, before comma, there's no space. After comma, there's a space, right? You can look at this grammar here. So some people might say, should I not write like this? Can I not put print like this and put first name like this and last name like this? It still works, no problem. You can see 2 times print has printed the same thing in here, right? But then this is the correct convention, the first one. This is not the right convention. So make sure that after you have a function name, you want to call a function, the open parenthesis must not have any spaces before it. And inside the function, when you are passing an argument, for the first argument, don't use any spaces. The same rules apply. Within open brackets, first element that you put there, no spaces surrounding it, right? No spaces between them, sorry. And after that, before a comma, no space. But after a comma, add a space. And even here, follow the same. You can see I'm putting a lot of emphasis in this tiny things, which some of you might think, oh, this guy is exaggerated. But this is what goes to make you look like a professional programmer, right? It's like you're presenting a program with coat and tie. It's like that. All that glitz, right? You want to have that. So your program should look spick and clean, and you have to follow all these things to make it look like that. So put a lot of emphasis on these things. I told you about all these aspects. You can see that this first 2 statements got executed. These are expressions, but treated like statements because I'm not really interested in the written value of it, right? I talked about this in the last session. So 2 prints is got printed, but after that, there is an error. If you put anything after this line, it's not going to get executed. So you can see that if I put some more line here and say, it worked, for example, I'm putting some dummy string in here. You can look at this error. It shows the error is in this line. You can see the arrow mark here. The arrow mark is pointing to the error exactly in this line. This is where it failed. It's very clear. It says it's type error in this line, and it says type error can only concatenate string and not integer to a string. Or which one was a string and which one was an integer, it's up to you to find out, because you can see that here. Sometimes it may not be very intuitive, especially if this was a variable. If at all you had like this, like say, let's call it as value, or I can just say maybe age is equal to, I'll say 32 or some number like this. And it's a first name plus space plus age plus last name. And we can see that it still throws an error. But when you look at this, you don't know exactly what was the problem. Now what you need to do, you need to find out what is the value assigned to first name. Look at the first name value, it's a string. Then obviously I have a value literally here, which is again a string, which is representing 1 space. Look at age here, and age, is this a string? This is not a string. This is not a string. So here, because I put 32 like this, it's not a string. But the moment you put 32 with quotes, this code will magically work. You can see that. Oh yeah, this expression is evaluated, but I'm not printing it out anywhere, because if this was the last expression, we would have seen the output of it. But after the expression, I put a print here. So print returns nothing. So it only prints this value and return nothing. So you don't see any out session here. So I'll just do one thing. I just remove this line and run this. You can see this. It shows John 32 Smith. This is like the output. This is an out colon thing, right? It's not showing out here, surprisingly. Okay, it's supposed to show out and out of 17 or something. But yeah, sometimes in VS Code, it sort of, truncates this out. But you can see this. But after this expression, if you add any other expression, outcome of that is going to be printed. The previous expression data could be lost. So if you want to store the outcome, what do? You can just say, maybe you can say result is equal to, then you can try print, it worked, result equals, comma, result. You can see slowly I'm evolving this program, right? It's becoming from one line to two lines. You can see it's slowly growing. It's not doing anything useful other than just making us learn about the syntax, grammar, and so on. So slowly in a while, we'll learn about something more useful. Okay, we'll try to make something useful out of it. You can see this. Try running it. It says it worked. Result is equal to John 32 Smith. Right? Now you can see that I've talked about literal data. Strings are represented within quotes. There are different ways of quoting strings, which I will cover in a dedicated session about strings. It'll be in a much later stage. But for now, I can simply use double quotes. You can use single quoted string, double quoted string, triple quoted string, R string, B string, yeah, F strings. There are so many variations, but this is a very basic way to represent a string. And this literal value, when you write in a program, what Python does is something really interesting. It creates an object based on the literal value. In Python, everything that you refer to, that you can refer to with an identifier, anything that you can refer to with an identifier in Python is an object. Python is a fully object-oriented programming language. It's 100% object-oriented in its core. But we don't have to know about object orientation to use it. So the moment I talk about object orientation, many people think classes, objects, inheritance, polymorphism, generalization, all kinds of jargons. We never dealt with it. But when I tell you that this is an object-oriented code, would you believe it? It is, because whenever you use any data that you represent literally in Python, when this code is getting compiled in memory, Python creates a structured form of it, which we call as objects. Right? It creates a data structure. If you're a C programmer, it creates a struct, allocates a struct dynamically in memory that represents the data. That structure, which is there in RAM, that is there in your memory, computer's memory, is stored somewhere in memory, right? The address of it is tagged. It is tagged with this label. I'm making it very simple right now. I'll talk one more layer deep much later when I talk about the internals more. So this tutorial is not just going to talk about the skin layer. I'm going to go deep into the internals. Just bear with me in the further sessions, right? I'll dig deep down and show you how things work. All of these labels that you see, these identifiers, these are like keys in some kind of a registry. For those of you who are more inquisitive, what is that registry? It's called a dictionary. Python maintains it. A dictionary is like a key value pair. It's like your register. When you open up a register, you'll see some kind of an identity to identify a record, employee ID, employee name, something that's unique to identify a record, and then you have all the details, right? So you have a registry that Python maintains, where all these variables or identifiers are stored, as and when you define them. So the moment you say first name is equal to John, it adds a key called first name, and the value corresponding to it would be the memory address of an object allocated that stores John. I know it's deep, isn't it? It is. These are the internals. You can learn Python without knowing the internals, but I should also detour a little bit of digression again. Many people learn programming at a very high level, just the syntax, grammar, and they're happy with it. It is like learning how to drive a car. Normally, yeah, there are two kinds of people who learn car driving. Those who just maneuver the steering and know how to use the brakes and accelerators and the gearbox, right? Gears, switch gears and all that. That's the normal user. For everyday driving, that's good enough. You know a bit of car driving and you can travel from one place to another place, and obviously you should follow the traffic rules. But if you want to become an expert driver, somebody who goes in long trips, long drives, climbing across mountainous terrains and all kinds of challenging places. Or you might be a motocross driver, maybe a race driver. Just knowing the basic car driving isn't enough. You know what? You should know the internals of the car. You should know how the engine works. You should know how to maneuver the engine most efficiently. So if you're a race driver, you should know in what time you should switch gears and how you make your car more optimal for the speed. Or if you're going on a long trip or a terrain, you should know how to service your car when it breaks down. And there's nobody to call. That does happen all the time, right? So you should know how to open up the bonnet and see what's inside and service a car. That is the internals. The more you know the internals, the more you can troubleshoot issues with your car. The more you know the internals of a programming language, you would understand what really went wrong when you're looking at some programs breaking, when they break unexpectedly and they fail unexpectedly and something goes wrong. You can look at troubleshooting with a better view, with better clarity. And that's the reason why I don't just cover the language grammar in this tutorial series. That is never my intent. As I told you, I want to make you a fluent programmer, which means I'm going to go deep dive into the internals through this tutorial, though it is meant for the absolute beginners. And if you find all these things overwhelming, let me know, right? Obviously it's in a video, you can pause, put some thought process, think about it, and think about how things work. So summarize here, I told you, every literal data that you create in Python, be it a number, be it a string, or be it any other forms of data that you can represent literally, Python reads that literal grammar. Based on the grammar, it figures out whether it must be a number or it must be a string. Strings must always be in quotes. It's pretty obvious, right? Numbers are just digits. They have their own grammar, which I will discuss in the next session. I'll talk about formal syntax for creating numbers, formal syntax for creating strings, and other types. Based on that particular syntax, it identifies, oh, this is a number, so it allocates a numeric object. An object is nothing but some kind of a data structure that Python internally represents, which we don't have to worry about for most cases. It is implementation dependent, and they also vary across versions of Python. So that's abstracted out by the language runtime. But you should note that there's an object created, and that object, which is dynamically allocated, stores the value. And the object is allocated in an address in memory. The address is stored as the value in a registry that Python maintains, which is a dictionary, we call it, with a key, which is the identifier. It's like you have objects around in this room, a lot of objects around this room. But I want to keep a ledger of what all objects are there and where they are. One of the biggest problems I face everywhere I go is I forget where I placed things. You'll see me struggling to find my room keys or my pen or things like this. I scatter it across and I forget it. So if I'm a very organized person, what do? I have one small sheet of paper or paper sheet where I'm going to say my keys, this place. My mouse is near. So silly, mouse, okay. Or my, my mobile phone is in this place. So I'm going to put the locations of all the objects I want to lay out in my room. So I walk into the room and I want to look for my mobile phone. Where I normally place it. I say mobile phone is in this location. I go to the location and pick it up. That's exactly what Python does with all these data. So all these data which are represented as objects are stored across in memory dynamically. And their addresses are stored in a particular form in a data structure. And the keys for those addresses are those identifiers. And when you ask Python, okay, tell me where's the first name, give me the first name. How does Python figure out where's the first name stored in memory? I use that word called first name. First name is a key. It's just an identifier. But based on that label, how does it know where it is? It's looking up in that registry, looking up the location, getting that data. Understanding this? This is not unique to Python. It's there in most languages. It is hidden away thoroughly. If you are an advanced C programmer, you would have heard about symbol tables and symbol table lookups, which are all the same. C++, we talk about V tables and all that. Okay, my C++ knowledge is totally rusted. I keep telling that in all my trainings. It's been almost like more than 15 years since I touched C++. Other than writing C out and C in and basic C program in C++, I don't think I know the internals anymore. Forgotten about it long time ago. But fine. But you would have heard about these terms, V tables and symbol tables and all that. They all use the same analogy in most languages. Just that in Python, everything is like a glass box. You can actually see them, which I will discuss in the future sessions when I talk about a specific session on introspection in Python. Right? Now that I told you about what this little data is, and I told you all little data is represented as objects in Python runtime the moment you define them. The moment you put this in an expression, there's an object that represents this John, there's an object that represents Smith, there's an object that represents this 32. All of these data is represented as objects, and these objects are tagged with these labels, which are the variables. Now, Python is a strongly typed language. Let me make a note of that here. Python is a strongly typed language. I talk about language typing. What do you mean by that? When I say a language is strongly typed, an integer or a number is treated as a number. It cannot be treated as a string directly. You cannot treat a number as a string. You cannot treat a string as a number directly. That's known as strong typing. Remember, I tried to add 10 plus 20 where 10 was in quotes and it failed. And I put 10 and 20 both in quotes, it worked. But when 10 was in quotes, 20 was not in quotes, it threw a type error. It said it's incompatible. You cannot concatenate string with an integer. You can add integer with integer. You can concatenate string with a string, but you cannot add string to an integer or concatenate integer to a string. This is the effect of strong typing. Numbers are treated differently, strings are treated differently. There are many more data types which will slowly will come across that. Okay, not in this session. In the next sessions I will talk about more data types. So it's a strongly typed language, but dynamic. So people call Python as a dynamically typed language. Dynamically typed. What I mean by that? These objects that you see come to life when these statements or expressions are evaluated by Python. So the moment I say here, for example, phone number 1 is equal to 20, until that statement is executed, 20 might not be there in memory. I am wording this carefully, might not. Okay. You'll understand later why. But maybe if I make it like, say, not instead of 20, if I make it like this, definitely not there in memory. I can assure you that. Let's keep it that way. So I say 20,000. Until this statement is executed, an object representing 20,000 is not there in memory. That means this object got created dynamically during execution. That is called dynamic typing. There are languages which are statically typed. The most prominent languages like Java or C, C++, or even modern languages like Rust, Golang. All of these are statically typed languages. Something which is very common with statically typed languages, they are purely compiled languages, not compiled interpreted, mostly fully compiled languages. They generate program binary. So when it comes to compiled languages, they're going to read the entire program at one go and create a machine code for it. Right? There's no runtime support. The machine code is independent. You don't need the language runtime to execute it. If you compile the C program, you get a binary. You don't need the C compiler or anything. That code will run independently. We call them as standalone executables. These programs run independently. See, to run this VS Code, I did not need the C compiler or C++ compiler. I think it's written in C++. I'm not sure. Maybe JavaScript, for all I know. So yeah, it could be different. It's a polyglot tool, right? But I don't need that runtime. Mostly, if it's written in C, I don't need the runtime for it. It's a standalone executable. It's a compiled binary. Because you'll not need any language support for the final program to run. You need to prepare it completely. All the storage, how much memory is required for all the data must be predefined. So one of the common signatures of statically typed languages are declarations. You declare variables. There's more beyond that. You'll see declarations of your functions and prototypes of functions and all that. That's dependent on language design. But you'll mostly see variable declarations, where you'll have to tell the compiler that I'm going to use a variable called I in the program, and this variable must be an integer. That means you're typifying a variable. A variable is typed as integer, float, or boolean, or even string. Maybe if you're using language like Java. So you typify a variable. Variables are tied down to types. What it basically does is the compiler will pre-allocate storage and generate the binary for it. And the storage cannot change. How much memory is used for integer is fixed. It cannot change. Right? It's permanent. With Python being a dynamically typed language, the beauty here is that, first thing you notice, variables are just labels. They are not associated with types. Variables don't have types in Python. Their phone number is just a label. It's like the sticker label that you have, maybe a sticky note. Do I have one? It's like these sticky notes. You can just stick it on anything. Maybe I can stick it on a mouse like this. I can take the sticky note from the mouse and stick it on my mobile phone. This is how variables are treated in Python. The point is, the variables don't have any types. They're just identifiers that identify anything. They are typeless. But objects that are allocated, they are strongly typed. Right? That's one thing you should know. So there's no declaration in Python. You don't say phone number is an integer, name is a string. You don't say that. You don't say what type an identifier or the variable is. The names that you see use here, they don't have any types associated. The moment you assign values to them or assign the result of an expression to them, these variables, just tag them, tag this object. And these objects have types. Objects are typed. I can say that this is a mobile phone. It's a type. I can say maybe this is a mouse, which is a type. I have two objects of the same type. Two objects. This is a mouse. So is this. Both are mouses. Right? So both of them are mouse. Yeah, so you might ask me why you have so many mouses here. That's a different story. Let's not talk about that. But then I can also take one more object. I have a pencil. I can have many pencils and it's of type pencil. So you have types associated with the object. Types associated with the object. Right? So that's exactly how Python deals with it. So Python deals with data like in the real world. Literally almost like in the real world. So you have objects. Objects are types. And these objects are created dynamically when you execute this code. During the execution of the code. So when it sees a value like 20,000, it knows, oh, based on the literal data 20,000, it has to allocate an integer. It just creates an integer object which represents the value 20,000, and then it tags it with the phone number at that instant. Everything happens in the runtime. This has a lot of debated things about runtime versus compile time, right? So they talk about type safety and compile time safety, runtime safety, and other things, which is debated. I will talk about that in the further sessions when I discuss about the merits and the drawbacks about this design. Right? Nothing is perfect. Different people have different takes. Right? That's how it is. Anyways, now I told you that Python, everything that you can assign to an identifier, anything that you can identify with a variable or any kind of identifier, those entities are objects in Python. And these objects are created in runtime during execution, and these objects are strongly typed. So once an object is allocated and this is determined as an integer, it remains as an integer. It cannot be treated like a string, right? And these objects are created during execution, not statically allocated. So certain takeaways I should tell you. There are no declarations in Python. I'll make a note here. These are some things that you should know to pass an interview. If I'm going to interview you, if I say I'll declare a variable called A, declare a variable? No, you don't declare a variable in Python. You define a variable. You define, you don't declare, right? So in Python code, there are no declarations. There are some caveats. When I talk about global qualifier, that's a kind of a declaration, which I'll discuss later. Okay. But largely, there are no declarations, but only definitions. What is a definition? I've told you what a definition is in my previous session. What is it? It's an act of tying down an identifier to an object. That's a definition. It's an act of tying an identifier to an object. When I say A is equal to 10, A is an identifier. 10 becomes an object ultimately. You're tying this A, you're tagging this A to this object. That is definition. You can do that with assignments. When you define a function, that also is a kind of definition because you are creating a chunk of code and you're tagging with the name, which is the name of the function that represents that code. That code is a function object, and this name represents that. Right? So these are some important concepts that you should try and assimilate. Right? I think I stretched the session again. I thought I will cover a lot in a short time, but yeah, gone beyond 1 hour. So I have to continue in part 3 again. Sorry about this. So yeah, what are the things that you learned in this 1 hour session? Well, let me summarize it. I talked about, I didn't go deeper into statements and expressions. I'll cover that more, right? But there are some concepts you learned. You learned about what objects are in Python. Objects are entities that make up your Python program. All of your data in Python are ultimately represented as objects. Values. All these are literal values like 1, 2, 3. These are values, right? Even strings. Hello is a value. It's a string value. All these literal data that represent values are transformed to objects in runtime during execution by Python. They're tagged with variables. The variables are identifiers, right? We also generally call them as names in Python. And all of these objects have a particular data type. For now, I only talked about strings and integer. The next session, I will go one more layer deep, part 3 to follow, where I'll go one more layer deep, where I'll give you some insight about different data types and a little bit about introspection. I'll introduce you to how do you introspect, how do you find out the type of an object and what are the things you can do with it, right? I'll discuss that in the next session. Hope you found this video useful. Please do comment your feedback on this particular session. Are you finding it interesting? I know it's a 1 hour session, which requires a lot of patience. We live in an era where most YouTube videos don't go beyond 10-15 minutes. But I tried to create a 10-15 minute video, but I was not making any justice out of it. The kind of concepts I covered will be too crisp and not really deep. But it might appeal to people who already have some programming background. For them, it's good. But if you're an absolute beginner, I think from my experience, I realized that I have to actually take some time, spend some time, explain with more examples perhaps. And I hope I'm doing justice to that. So please do let me know in the comments, right? So thank you very much. So if you really like this video, as usual, the usual YouTube formalities, like, share, subscribe, and all that stuff, right? Thank you very much. So hope to meet you the next session.